All right, so today a little bit with graphing absolute value equations. And we've got to understand the parts of the equation so we can graph it. Because it's this big, long, funky looking thing here. And we've got to be able to figure out what each of those parts mean when we go to put it on a graph. So here's how this works. My A value kind of looks like my coefficient out front. It's kind of, well, let's do this. It's going to determine the width of our graph, whether it's skinny or fat, and the direction it opens. Now, I know some teachers do this. I'm not comfortable calling this slope, but it's kind of like slope. So if that kind of helps you see, I'll put the slope in quotes here, because it does tell us if it opens up or down, how steep it's going to be, okay, things like that. But I don't just want to flat call it slope, because that would drive me crazy. But if you want to look at it that way, you can. So that number in front will tell me that. Then this H and K stuff is my vertex. When you're doing an absolute value equation, it kind of looks like a V. Not a U like the parabola, but a V. And where that V turns direction or comes together, that's going to be my vertex. And that's going to be a major part of how I figure out how to graph these. So within that vertex, it's sort of like X and Y would be. Except H is sort of my X value of the vertex. But there's a couple of little hints we can get from that to help us out. When we're looking at it in the actual equation, because you'll notice here it says x minus h. Whenever you see x minus h in the absolute value, that means we're going to be shifting our graph to the right. It's kind of the opposite of what you would think it would be, but that's the way it works. If I see x plus h, I'm going to be shifting my graph to the left. Again, kind of odd when you first think about it, but it's the whole reason behind it's x minus h, so it does the opposite to us. Now, the k part, which you'll notice is outside, is the y value of the vertex. With this one, if it's a positive number, we're going to shift up. And if it's a negative number, we're going to shift our graph down. And those are the two things that we're going to talk about a lot with the H and K. So knowing those is really important. And then to figure out if my graph is going to be going up and looking like a V or going down and, I don't know, looking like a mountain, I guess. If my A value is positive, so that number in front's where it's at. If the A value is positive, it's going to open upward. My arrows will be going up. If my A value is negative, it's going to open downward. Okay, and that won't change on these. And that's kind of our basic breakdown of all the pieces of an absolute value function and what they do. So no better way to get used to them than to actually jump in and start working with them. So, now this is the part that's fun. Okay, the vertex is where we're always going to start. It's the centerpiece of our graph. The k value is always the easy one to work with. You just write down what you see outside of the absolute value. It's remembering that h value. It's the opposite. If I see plus 1, my vertex value is going to be negative 1. Because again, the initial value is minus h, so the opposite, or minus 1, would be a negative 1. So that vertex, negative 1, 3, okay, that's where my graph is going to center from. And it's going to be symmetrical. It's going to be the same on both sides of it. Well, how do I figure out the other points? Well, there's a couple of things you could do. But again, I want to keep this as simple as possible. So I'm going to use my S word here, use slope. Okay, since my A value is 2, okay, treat it like you would slope. From that first point you made, I'm going to go up 2 and over 1. Now here's the part that's going to be crazy. I'm also going to go up 2 and left 1. Like, but wait a minute, it's not negative slope. When you're dealing with absolute value functions, remember, absolute value kicks everything out as positive. So since we want to be symmetrical, we're going to treat it like we would slope. So since we know it's opening up, since it's positive, and we know it's going to be symmetrical, I know when I go up 2 and right 1, well, its mirror image will be to the other side. And then we just connect the dots, and I've got myself a graph. Now some of you may say, okay, I'd feel a little more comfortable with this if I could see it on the calculator, just to be sure things are going okay. Let me show you how that would work. All right, let me get this on. Let me get out of my funky mode here. Okay. If I want to do this in the graphing calculator, I'm still going to go back to y equals like I normally would. So when I get here, okay, my coefficient's 2. How do I signify, because I can't use parentheses because they're absolute value bars. To get there, I'm going to hit math. I'm going to arrow over to NUM, which is my numeric menu. And you'll notice the very first thing there is ABS, which stands for absolute value. So I would hit enter at this point. And whatever I want inside the absolute value is what I put in this set of parentheses. So x plus 1, make sure you close it up, and then plus 3. So that says 2 times the absolute value of x plus 1 plus 3. Okay, that's what I want. So I could graph it. I see it kind of looks like the one I have. But if I really wanted to use this for mine, I, of course, would hit second graph to look at the table and see where my values are. And you'll notice some of the values here, like negative 2, 5. Okay, there's my point right there for negative 2, 5. Then I've got negative 1, 3. That was my vertex. And the cool thing about the calculator is, if you get your vertex right, you notice you see the symmetry around the outside. I go 1 number more, 1 number less, both the answers are 5. 2 answers more, 2 answers less, it's 7. And 9. Once you find that center point, everything just does a mirror image. Okay? But you really only have to have the 3 points to make an accurate graph. So if you want to use this as a check, you can. So let me just make a note here for you, just in case you want to. So if you're going to do the graphing calc and you want absolute value, once you get into y equals, it's math, that numeric menu, and then number 1. And that will get you the absolute value that you need to be able to plug it into your calculator. Always nice having the backup plan. We'll keep the calculator handy. We might come back and do another one with it here in a minute. But for most of our problems, we're going to be looking for 3 things basically. We're going to graph them, explaining what the vertex is. And then we're going to go back to domain and range again and keep coming with that. So here, now this looks a little interesting. You're like, wait a minute. I don't see an h value. I don't see a k value. And that's true. And when you don't see one of those, we're going to assume there's 0. So this would be the equivalent of having y equals negative x plus 0 plus 0, except we're not going to write all the zeros in. So whenever you have a piece missing, we just assume it's going to be 0 for those. Okay, so my vertex for this one's at 0, 0. Now let's see what else I can figure out here. My a value is negative, so I know my graph's going to open down. Okay, I know that much. So then if I think about it as far as slope goes, it'd be like having negative 1. So you're like, okay, if the slope was negative 1, I'd go down 1 and right 1. But this is weird again. It's absolute value. So I'm going to go down 1 and left 1 as well. Get my 3 points. They'll always be in the shape of a triangle. And connect the dots. Opens down, symmetrical, feeling good. But then, again, I still got to do the domain and range here. The domain you're going to love on these, because the domain's going to be the same thing every time. Domain, remember, is my x values from least to greatest. Well, if this is going to keep going forever off to the left, and this is going to keep going forever off to the right, my domain's going to be negative infinity to infinity. Now my range, however, is a little trickier. Remember, range is from bottom to top. Well, the bottom looks to be going down forever. Okay, so that's negative infinity. But where's the top point? I don't think it goes up forever. 0. Bracket. Because that value is included, and I'm set. But again, your domain basically for these is always going to be negative infinity to infinity, unless we get something weird going on here. But you'll start to get the hang. You'll start going, okay, let's see. Here, what's my vertex? I don't see anything out here, so that's like having a plus 0. So when I'm doing vertex, oh yeah, it's opposite of the sign I see inside, and then keep whatever's outside. Opposite of that's 3. 3, 0. Okay, 3, 0. Is this one going to be opening up or down? Up, because my value in front, again, is 1, since I can't see anything. It's positive, so it opens up. But again, my slope, per se, is 1 over 1, so up 1 and right 1, or up 1 and left 1. And if you really want to make your graph even more accurate than this, doesn't hurt to do an extra. It'd be just like slope. Up 1 and over 1, up 1 and over 1, if you want to get some extra dots working. Make my lines, because again, we're doing V shapes, being absolute value. And again, my domain and range, all the way to the left, all the way to the right. That should be one we shouldn't miss, because it seems to be the same each time. Now range, be cautious. Bottom of your graph to the top. Where is your lowest y value? 0. Okay, it's going to be tempting to put 3. But again, that would be your x value. My lowest y value is at 0 and goes to infinity. And you're like, this kind of looks like a pattern of sorts maybe developing here. Y value of my vertex is 0. That was 0. Y value of my vertex is 0. 0. Now they're in different places, but that might have something to do with this. Let's see here. All right, let's see. Number 4. What's my vertex for number 4? -2, because we do the opposite. And 0, because I don't see anything else popping around out there. So -2, 0. My slope still looks like it's 1, because my a value, I don't see anything out there, and we assume that's going to be 1. So up, right, up 1, right 1, up 1, left 1. Give me a couple extra dots working. If that was a little more accurate, that would have looked a little more symmetrical. Let's see if our pattern continues here. My domain still going forever, left and right, so that's all good. What about my range this time? Bottom to top.
0 to infinity.
Bottom to top, 0 to infinity. Our streak continues. Now, we'll start throwing a couple of twists in here. Let's see how this goes. When we get to 5, it's sort of like number 2 in that there's no other number in here with x. There's no number being added on the outside. So my vertex is back being 0, 0. However, this time, my slope, air quotes, is 3 or 3 over 1. So now I'm going to go up 3 and right 1, up 3 and left 1. And again, if you want to be more accurate, you can do it again. 1, 2, 3, 1, up 3, left 1 with absolute value. Draw my arrows in. And then again, it's just about we love domain because I get to write the same thing every time. In my range, you're like, dang, it's that again. Bottom to top, 0 to infinity. Is that ever going to change, Harty? Yes. Actually, very soon. So I start to look, and I'm like, okay, what other weird things are going on here? So 6, let's see. What's my vertex going to be in number 6?
0, -1.
Okay, 0, -1, because there's nothing in with my x, so I don't have an x value shift, but I have the -1. So 0, -1, nice big dot. Slope still hasn't changed. So we go up 1 right, up 1 left, right, up 1 left. Draw it out. I'm like, this is pretty cool so far. It's not bad. So let's see. Domain I'm not even going to ask because, well, it's the same thing. But my range changed a little. Where's my least value in my range now? -1. So that stays consistent as to what we've been having. My y value in my vertex has a direct impact on my range. And I kind of keep working that a little bit. So I'm like, all right, let's see. Any other weird stuff we can have thrown at us here? Yes, yes there is. We're going to take a look at 7 and 10. Because this is getting a little bit odd now. So 7. Vertex for number 7. Oh, vertex. I think some of you are all locked in so much. I am non-existent. So -1, -2. So again, switch the sign inside. Keep the one outside. Leave it alone. So -1, -2. My slope's still not changing. This is getting kind of boring with that. So up 1 over 1 each way. Do that one more time. Again, that domain is not changing. Nope, 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 nope. But again, my range, keep reminding yourself it's y, starting at -2. Or just steal it from your vertex. Keep life simple. And then the last one I want to look at this side specifically, unless there's one somebody wants to peek at, is number 10. So let's see here. Vertex for number 10. They're locked in. So switch it on the inside, keep it on the out. So -1, -3. Dot that up. Now this time we finally get a change in our slope per se. It's 1/2. Still do it like you would slope. I'm going to go up 1 and right 2. We'll go up 1 and left 2, because again, we're symmetrical. We'll do it one more time. Up 1, right 2. So the smaller the value of your slope, per se, the wider your graph is going to get. If it's a bigger numbered slope, the skinnier it's going to get. And one last time here, our domain, still not changing. And our range still directly correlates to our vertex. Are we doing all right? Because there's only one more piece to this that I want to show you a peek at, and then if there's something else we want to take a look at, we can. Okay. I'm going to go away from this one to your half sheet for a second. Because there's another piece to this where you're given a graph that's already drawn, like the two examples we have here, but then your job is to come up with the equation. So just a reminder again, got the reminders about the vertex and the slope up top. You always have to find out what's your vertex and what's your slope. And remember, with your slope, if it's negative, it would be opening down. If it's positive, your graph's opening up. So you can get some clues before you ever start with this. So I start to look and I go, okay, let's see what I know right off the bat here. First question it says I always have to ask myself is, what's my vertex? So for this first one, where's my vertex? Where's my turning point? Where does my graph split? Let's do it that way. Where is the bottom of my V? Negative 8, 0. Okay. So that means my H is negative 8 and my K is 0. And then my slope, now that's not going to be a dead giveaway, but you're always going to have several points to work with. I know it's going to be positive because it opens up. So even though I may say I'm going to count from this dot to this one, and you're like, but I'm getting a negative slope when I do that. Keep telling yourself it's absolute value. So to get my slope, I go up 1, 2, 3, 4, and over 2. So rise 4, run 2 means I have a slope, an A value of 2. And I need those three numbers to make my absolute value equation. So here's how this works. Okay, it's opening up, so we got my A value is 2. Now, be careful. X minus H. X minus negative 8. Plus 8. So it's going to be the opposite of whatever your vertex's H value is. And then if you have a K value, that would go out here on the end. But I don't have to have the plus 0 there. If it's 0, I just assume it is. So if you just drew that, wrote that, that'd be okay. But that's how this is going to work each time. I always want to look, for instance, on my second one here, I always want to look and say, okay, my vertex is at 10, 0. So again, my H value is 10, my K value is 0 in this case. I also notice my graph's opening down. So my slope, my A value, is going to be negative. And this is the part that's not quite as much fun. I got to get from one point here, from my vertex to one of these. So I'm going to count my rise and run so I can figure out my slope here. Or, well, I'll talk about the or in a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 1, 2, 3, 4, 5, 6. Rise over run, 12 over 6, is 2, but again, it's going to be negative because it's opening downward. And once again, I have my A, I have my H and K. Now it's time to fill it on in. So I'm like, all right, -2 is my A, X minus H, and again, I can put the +0, but I don't have to. If you don't want to count all the lines for slope, you always can use the slope formula with 2 of the points. You always could say, oh yeah, I subtract my y's over subtracting my x's. Oh yeah. 12 over, and again, but I got to remind myself, it's not necessarily going to be negative. I got to figure that out from which way my graph's opening. But you can figure out your slope that way. So what this is all going to mean to you is that worksheet that you picked up front. It's sort of a 50-50 proposition of sorts. This guy here we're looking at homework check 3, assignment number 3 here. And on the front, you're doing what we just did on the half sheet. You have all these graphs. They give you a vertex. You've got to figure out the slope, and you've got to create the equation for them, just like we did there. On the back are like the problems that we were doing on the big note sheet. You're going to name the vertex. You're going to graph them. You're going to do domain and range for those, and they're really similar to the ones that were there. So this is the work for you to do. And then